Howdy and welcome back. So we'll begin this lesson with a brief kind of video on the setup. We're going to introduce, or I guess revisit, our movie example. So we'll start out here with, well, what was our movie type? How did we structure it? How did we define it? Some of the movies that we were interacting with, and then we'll slowly start moving into the content for today's lesson. So recapping our motivating example, let's imagine that we have a collection of movie objects, and we're going to say that a movie object has four fields: a title, director, rating, and release year field. The first two, title and director, will store a standard library uh, string. Rating will be an enumeration type, and release year will be an unsigned integer. The C++ class definition for this is over here. We're defining a movie as a struct to keep things simple and allow us easy access to the data members as we're running through this example. And how we kind of began all of this was creating a standard template library vector of movie objects, and we were considering three movies. Residing at position 1, index 0, within this movies vector, we had Citizen Kane, directed by Orson Welles with a rating of PG, released in 1941. Rear Window by Alfred Hitchcock with a rating of PG, released in 1954, occupied index 1 or position 2 within this vector. The third and final movie that we were kind of interacting with was Pulp Fiction, directed by Quentin Tarantino with a rating of R, released in 1994, and this was at the last position within our vector. It is at position 3, index 2. So why did I guess why these movies, maybe you're curious. So Citizen Kane and Rear Window were two videos I watched in my film literature class during undergrad. Pulp Fiction, I mean, Quentin Tarantino is kind of another creative director, so I threw that one in here as well. But anyway, so this is the composition of our vector of movies. This is the collection we'll be dealing with throughout this lesson. And if you recall, we had this collection, and the next kind of process or focus was that we said, okay, well, let's say we want to write a function that finds all movie objects matching some sort of criteria from our movies collection. When we were introducing different styles of programming, we mentioned kind of an iterative solution that would allow us to achieve this ends. We said that by writing iterative code, we were essentially forced to tell the computer exactly how to do everything. So in this case, if we want to select some subset of videos from our set of videos, we could go ahead and create a brand new standard template library vector of movies, call it filter movies, and then go through our movie collections. So for each movie and movies, we'll go ahead and check against our criteria. Say we wanted all movies that were released before the year 1990. Well, in this case, we just write a conditional if movie.release year is less than 1990. Let's push it to that filtered movies record. And then at the end of this iterative statement, what we would have is a collection of movie objects that fit our criteria that we specified. In this case, all of those whose attribute release year has a value of less than 1999. We kind of were talking about this and, getting into it a bit more, and started going, well, is there a way that we could maybe write declarative code that would allow us to tell the computer what we wanted and then let it figure out how to accomplish it? So moving away from writing these kind of explicit iterative statements every time we wanted a specific set of movies from our collection, we could begin doing something like writing a filter function where we pass in the collection of movies some sort of function, which would be the filter specification. And then that filter movies function would be responsible for the heavy lifting to determine whether or not a particular movie meets the criteria that we're looking for. And if so, to insert it into a, collection of movies and return that to the caller. So we began developing this filter movies function here. It returned a standard template library vector of movies. Filter movies had two parameters. One was a reference to a movies collection, so standard template library vector of movie objects. The second here was a function predicate, which we use to determine whether or not a particular movie should be included in that vector returned. So we began out very similar to kind of our to this code above and said, okay, well, we need to create a collection which will hold the results of this. And we went ahead and walked through each movie and we invoked that filter function on the movie. If when passing movie to the filter return true, we would push back that particular movie to our filter's movie vector. Otherwise, we would continue on. Well, in either case, we'd continue on to the next movie within the sequence until we were at the end of the sequence. And the result of this was only movies who, when passed to the filter function, a true value was returned back, would they be pushed to the filter movies collection, which was ultimately returned. And we can see that here. Here's that vector declaration. Here's that pushback operation, which is associated with that conditional. And here we are returning it. Okay, so we then kind of moved into, well, this is the direction we want to go. So when we're in, say, some other function, somewhere, and we decided, hey, I need some set of movies, right? And we kind of specifically focused on the release yarn example, but we said we want to be able to write declarative code like this, in the sense that opposed to always having to write some sort of iterative statement to go through and perform this kind of operation, we wanted to have a function that would do that for us. So if we wanted a subset from our movies collection, we would just call filter movies. We'd pass the collection, and then we'd pass in the filter specification. And the filter specification was simply a function predicate. So a function that returned true or false. And it took in our case, we introduced this released before 1990 function up here. And we kind of built up a lot of the last lesson using this. Okay, so we have this function that returns true or false, released before 1990, takes a movie object by constant reference, and it returns true if the movie release year was less than 1990, false otherwise. So true if the movie's release year was less than 1990, false otherwise. And then we saw that, okay, we could go ahead and pass in to our filter movies function, our collection of movies, which was used to initialize the movies parameter. And then we said we could also pass in a function, so in this case, release before 1990, that provided its signature matched that specified in the standard template library function type, if you will. If it returned a Boolean value and it took a constant or a movie object by reference to const, this would be initialized, filter would be initialized with release before 1990, and then any calls to filter within the body of filter movies would invoke this function here. So this filter operation, filter movie, was actually invoking release before 1990. And had we passed in a different predicate function to our filter movies, that function would be used under the name filter. So kind of building all of this up, we introduced two new ideas that we hadn't really seen before. We introduced higher order functions, which was a function that operates on or uses another function. So our filter movies function was a higher order function. We then shifted into this discussion about first class functions and mentioned that, hey, many programming languages support this so-called first class function kind of concept, more or less meaning that functions can be stored as variables and passed to other functions. We said the modality of doing this in C++, at least in the way we introduced, was by passing pointers to our function. So a pointer to kind of the base location as to where that function resided in the static code region of our memory. And then upon invoking the call operator on that, so filter, call operator, movie, well, released before would be invoked in this case, because filter, as we'll see, is kind of storing the address to that function. And when associated with the call operator, the compiler knows what sort of action should be taken when it sees filter movies. And that action is pausing execution of filter movies, stepping into release before, passing that movie as an argument to initialize the reference parameter, running through the code, getting the result, and passing that back and returning and continuing execution in filter movies. So we got into that and we mentioned there's kind of different ways to pass functions, if you will, to higher order functions in C++. And we alluded to, well, just passing in the function as a function pointer. We talked about function objects, which were callable objects, and we just briefly mentioned them. And today we're going to get into them in more detail. And then we'll eventually get into Lambda functions in a subsequent lesson here. All of this we said was moving us towards this kind of functional style programming in C++. So what we had said was what we were doing today, so in the previous lesson, was moving towards C++'s support for functional style programming. And we said that as a style, functional programming is going to emphasize solving problems by composing functions rather than writing loops or iterative statements, which leads to more declarative code rather than imperative code. And along with all of this, we get these awesome reusable higher order functions. And again, if you just look at this, and if we were to begin writing code like kind of what we're seeing here, that's one interesting approach. And that's kind of a lot of work every time we, have to do this. Of course, if, we wanted to reuse it, we could go ahead and give it a name as a function. But what was cooler was kind of this declarative approach, whereas if we needed some sort of movie objects, we could just go ahead and pass the collection to filter movies and ask for all of the objects that met some sort of criteria. And the criteria was left open. It would be dependent kind of on whatever filter specification that was passed to the filter movies. So with all of this, we're going to go ahead and move into function pointers. I'm going to try to set this up in a way that makes some associations to some things we've already talked about. Hopefully by the end of it, it will make sense. There's some, the syntax for this is not very pretty for function pointers, but once you get the hang of it, it's not so bad either. We'll then move into function objects. And then we'll go ahead and talk about defining higher order functions that accept both function pointers as well as function objects. So with that, I'll see you in the next video.